Hello, welcome back to our lesson class. So today we will learn on the limits of accuracy and also upper and lower bound of measurement. Okay, so by the end of this lesson, you should be able to calculate the absolute error and determine the lower and upper bound of a measurement. In this lesson, in order to calculate the limits of accuracy, you need to follow these steps. The first one, you have to identify the unit of measure. Second, calculate the absolute error. And lastly, calculate the lower and upper bound of the measurement. So first, what is limit of accuracy? Limit of accuracy is because the reason is that because all measurements are not accurate, there's an existence of an error called error. So if a number or measurement has been rounded, it is important to consider what possible values of the exact value. So how do you calculate these limits of accuracy? So we will follow the three steps. The step 1 is that identify the unit of measure. Unit of measure, what is that? It is the smallest division of a measurement. For example, decimal places, significant figure, nearest whole number, nearest millimeter, and more. Okay, so in this here, you can see examples. The first example is that 250 meter correct to the nearest 10 meter. So the smallest division of measurement is 10 meter. Very good. How about the second one? 27 second correct to the nearest. So nearest second will be this position. Okay, so the smallest division will be 1 second. Very good. So next, what I want you to do is that complete all of these 4 examples and try to do it on your own. Okay? Alright, so I believe all of you have done all these 4 examples. So here, please double check with your answer. If you have any question, you can ask me. So once you identify the unit of measure, you need to calculate the absolute error. But first, what is absolute error is? Absolute error is the absolute value of the difference between the measured value and also true value. So how do you calculate this one? By using this formula is equal to half times units of measure. So for example, if the unit of measure is 10, then the absolute error will be half multiplied with 10 is equal to 5. Very good. So that is how we calculate the absolute error. And the last step is that we have to calculate the lower and also upper bound of the measurement. So how do we calculate upper bound? To calculate upper bound, we can just simply add the absolute error, and also to calculate the lower bound, we can just subtract. So here is the example. From here, you can see the value given is 250 meter, and the unit of measure will be correct to the nearest 10 meter. So this is the unit of measure. So how do you calculate absolute error? Is equal to half multiplied with 10 is equal to 5. So next, calculate the lower bound, which is subtract the absolute error, and you will get 245 meter. For upper bound, we add the absolute error, and then you will have 255 meter. So this is how we calculate the lower and upper bound of measurements. As you can see from this side or this table, there's another example where you can try to do it and read through this example. Okay? So let's try to do it from step. As you can see inside your notebook, there's an example, table of example. Let me explain to you how to do it. The first one, The measurement given is 26 kilometer, and the smallest division of the measurement will be 1. So absolute error will be half multiplied with 1 is equal to 0.5. Okay, so the upper and lower bound will be represented like this also. And how do you as inequalities? You have to calculate the lower and upper bound. So this side is always lower bound and this side will always upper bound. This means that the measurement is between 25.5 kilometer to 26.5 meter. So next, for the next, and try to calculate the absolute error, the upper and lower bounds, and represent them as, okay? So pause this video now. Alright, I believe all of you have done the first example. Now let's move on to example 1. So example 1 will be a simple word problems. Okay, a girl's height is given as 162 centimeter to the nearest centimeter. The first lower and upper bound. The second one represent this range of numbers on a number line, and lastly express this range as inequality. So the first step, you have to identify the unit of measure. In this case, it says the nearest centimeter, which is, yes, very good, which is 1. So the smallest division will be 1. Okay, so the absolute error will be half multiplied with 1 is equal to 0.5. So next, calculate the lower bound and also the upper bound. So here is the answer. Please double check with your answer. Okay, and the second one is the represent this range of number on a number line, and lastly as inequalities. If you forget how to represent the numbers on number line or inequality, please double check or revise back your inequality lesson. Okay, so ta-da! So that's the end of our lesson. Okay, so what I wanted to do is do activity part 1. If you have any question, you can ask me and let me know. Alright, thank you students. See you next time.